This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The next example in tangents is to find the tangent equation from a point. So this time, instead of the point being on our circle, it's going to be a point outside the circle. So whereas before we were looking at doing a tangent to say a point here, and our tangent looked something like this. Instead now, what we're going to be doing is getting a tangent from say the point here, and we could get, in this case you can actually see we could get two possible tangents, one going this way and one going this way. Oops, bad drawing. This way. So let's have a look at an example. So we're asked to find the equations, so multiple equations of the tangents from the point 1, 0 to the circle x squared plus y squared minus 12x minus 10y plus 51 equals 0. So what we're going to do is we're going to look at the lines from, if we have the center of a circle being here and lines going from that center to these two tangents, well, we know that those tangents will be at right angles to the lines to the center, but what we'll also know is that the length of these two purple lines, these two lines now in green, will actually be equal to the radius of our circle. So we're going to have that the perpendicular distance from our center to our tangents will be equal to the radius length of our circle. So the first thing we need to find is where the center of our circle is and the radius length of our circle. So the center of the circle is just minus g minus f. So in this case, dividing minus 12 by minus 2 gives 6. Dividing minus 10 by minus 2 gives us 5. So we have our center of 6, 5. So that is this point here is 6, 5, for example. And we know the point we're drawing our tangents from is the point 1, 0. The next thing we said we needed to find was the radius of our circle. So that's the square root of g squared plus f squared minus c So that's the square root of 6 squared plus 5 squared minus our c, this case is 51, so minus 51. Working this out gives us the radius length is square root 10, so that's this r here in green. And what we're going to do is we're going to say the slope of our tangent is just an unknown value m, because we don't know what the slope of these two red lines are, so we're just going to call it m, and that'll be something we'll have to work out, because to get the equation of a line we need a point, which we have, the point 1, 0, but what we need to find is this slope m. So our only unknown now is this m here. So how are we going to find that? Well, like I said before, the radius length in each of these tangents, the radius length to each of the tangents is the perpendicular distance, because tangents are always perpendicular to the line through the center. So this perpendicular distance here in green has to be equal to that radius. So that's what we do down here. The perpendicular distance from the tangent to the center is equal to the radius. So our perpendicular distance formula is going to be equal to our radius, which we worked out above is root 10. So what we're going to do first is find the equation of the tangent in terms of m. that unknown that we had above, that unknown there, m. We still don't know it. We know a point that's on the line, but we don't know our slope. So filling in the formula, y minus y1 equals m times x minus x1. Our y1 is going to be equal to 0. Our x1 is going to be equal to 1. So we get an equation y minus 0 is equal to m times x minus 1. Multiplying out the bracket on the right, we have y is equal to mx minus m. So what I'm going to do first is bring everything to one side of the equals. So mx minus y minus m equals 0. And what this is the equation of our tangent lines, but we need to find out what m is. So what we're going to do is we're going to use this line equation with the center point 65 in our perpendicular distance formula to find out what m is. So to do that, we need to identify what all of these a, b, c, x1 and y1 are. So in our equation, mx minus y minus m equals 0, we can see that a, the number in front of x, is m, b, the number in front of y, is a minus 1, c, our constant, is a minus m, and our point is the point 65, so that means our x1 is 6 and our y1 is 5. So when we fill all of these values in to our equation, we know it's equal to root 10. So if we fill our values in, this is what we get here on the left. Simplifying it down a little bit, 6m minus 5 minus m. So we have a 5m minus 5 on top and a square root m squared plus 1 on the bottom equals square root 10. If we square everything, so squaring the top of this, the bottom and the right hand side, so if we square everything we get this equation here. The reason we do that is to get rid of these square roots, these awful square roots which make things a bit awkward. And then we're going to have to try and find out what m is. So we'll do that on the next slide. So in the previous slide, you'll recall we had 5m minus 5 all to be squared over square root of m squared plus 1 all to be squared is equal to the square root of 10 to be squared. So here and here, the square roots just cancel out with the squares, but in here we actually have to work this out as 5m minus 5 times 5m minus 5. So we get 25m squared minus 50m plus 25, and that's what goes in on the top of our fraction over here. Then what we do is we multiply both sides by m squared plus 1 to cancel out this fraction. So the top line up here is what's on the left, and we have 10 multiplied by an m squared plus 1. Multiplying this out, we get 10m squared plus 10, bringing everything to one side of the equals, leaves us with 15m squared minus 50m plus 15 equals 0. Dividing everything by 5, we get 3m squared minus 10m plus 3 equals 0. And then we have to factorize this. And once we do that, we can find that m is a third or m is 3. So then what we do is we go back to that general equation for the tangent we had in terms of m. But now we know what our two values for m are. We have either m is a third or m is 3. So filling that value of a third in for m, we get 1/3 x minus y minus a third equals 0. And multiplying everything by 3 just to make it a little bit neater, our tangent line is x minus 3y minus 1 equals 0. If we instead do m is equal to 3 and fill it in instead of m, we get an answer of 3x minus y minus 3 equals 0. And these two equations here are our answer to this question.